freezing point depression and boiling point elevation. Let's talk about these two colligative properties. In this video, we will learn how freezing and boiling points are changed with increasing solute concentrations. We'll learn how to calculate this change, or back calculate the concentration of a solution based on its freezing or melting point. Melting point changes are a very common measure of purity in organic chemistry, and so this is going to be a very useful skill as you continue on in science. The easy way to remember what happens to the freezing point and boiling point is to remember that the solution has a larger liquid phase than its pure solvent. This is because the freezing temperatures are lower and the boiling temperatures are higher. These follow a very similar and simple formula to each other. The change in temperature is the molality of the solution multiplied by a constant. The constant changes based on whether it's boiling or freezing, and for each type of solvent. Just as a quick reminder, when you are looking at molalities of electrolytes, you must account for the breaking up of the formula units into ions. So you'll be looking at the total molality of the ions after they have broken up. For something like NaCl, this will mean that you need to multiply the molality by 2 because there is one Na and one Cl. For something like MgCl2, you'll need to multiply it by 3 because there is one Mg and 2 Cls. So make sure you account for this. In some sources, you'll find that this is put into the formula. In some, you won't, but you need to make sure that you do it regardless. Now let's start our example by talking about something that comes up in everyday life, or maybe everyday life. Perhaps when cooking pasta, your mom or dad told you to put salt into the pasta water. They said that this would help it cook faster. Think about this and what we learned, and see if you think that this would be correct based on what I just told you about boiling points. Make a decision on this before pressing play. It definitely seems plausible. If adding salt raises the boiling point, making the water hotter, it seems reasonable that it would make pasta cook faster. However, if you've ever tested this yourself, it really doesn't seem to work. So why would it not seem to work? Think about that a minute before moving on. Let's do a quick calculation. Let's do an example problem that shows you how to calculate boiling point elevations while answering why salty pasta water doesn't seem to make that big of a difference in everyday life cook time. If we have a 500 milliliter pot of water, which therefore weighs 100 grams, or 500 grams, and we add a teaspoon of salt, which is really, if you think about it, a really large amount of salt, we can find out the new boiling point of water. So converting the grams of NaCl into moles, and remembering to multiply by 2 because of the Na and the Cl breaking apart, we get 0.1950 moles of ions. We divide this by the 0.5 kilograms that we got from the 500 ml sample, and multiply it by the Kb. This gives us a change of about 1 degree Celsius. So changing the boiling point from 100 degrees to 100.999. Now this is a very, very tiny change for quite a bit of salt. So although technically this water is hotter, it may make it cook faster, but it would be so small that it isn't even really a noticeable effect. In review, the boiling point of a solution is higher than that of its pure solvent, while the freezing point of a solution, or the melting point, is lower than that of a pure solvent. The boiling point and freezing point of a solution is determined by using the formula of a constant times by the molality, when considering also the Van't Hoff factor. And we did the example of boiling point, but the example of freezing point is very similar. Just make sure that you're getting the constants for both the correct solvent and the correct whether it's freezing or boiling.